Imagine a giant, immensely powerful storm rotating over your head. You'd be terrified if you could see it. But this storm is invisible to the unaided eye. It isn't your regular hurricane. This intense phenomenon happens in space. Space hurricanes are giant swirling storms that form not in our oceans but up in the ionosphere. It's part of Earth's upper atmosphere charged with energy from the sun. Space storms look a lot like traditional hurricanes, except they're made up of plasma, supercharged gases, and instead of raining water, they rain electrons. These massive rotating hurricanes appear over Earth's polar regions. Now, think of a space hurricane as a giant funnel or whirlpool of energy spiraling over the polar regions. It's only visible from high altitudes or by satellites. Space hurricanes also produce cyclone-like auroras. Such colorful light shows look similar to good old auroras, but there's a big twist. Space auroras usually spin near the North Pole for several hours, raining charged particles into the upper atmosphere. Hurricanes on Earth are born from warm ocean water and low-pressure areas. They're fueled by Earth's rotation and heat energy from the ocean. Space hurricanes, on the other hand, are created by a different process altogether. They're influenced by magnetic fields instead of Earth's water. When the solar wind, a steady flow of charged particles coming from the sun, comes into contact with Earth's magnetic field in just the right way, it creates a kind of swirling vortex of energy high up in the ionosphere. It starts spinning, much like how a regular hurricane spins in the atmosphere. Now, let's go all the way back to 2014. That was the first time researchers spotted a massive space storm over the Arctic using satellite data. That hurricane was huge, but at that time, they didn't know exactly what it was. What they did know was that its base stretched over 600 miles in diameter, and it had multiple spiral arms that looked just like the arms of a traditional hurricane. The storm also had a calm eye in the center. There, the plasma was still compared to the fast-rotating outer regions. Some parts of this storm spun at speeds up to 4,700 miles per hour. It's an incredible speed compared to Earth's hurricanes. The team observed the phenomenon for 8 hours. After that, it gradually broke down. Scientists managed to identify this storm as a space hurricane only in 2021, using observations that had been made several years before. Space hurricanes have several distinct features. First, it's cyclone-shaped, massive, bright auroras that can last for hours. Then there's the eye of the storm, a calm, stable center of the hurricane. A space hurricane also creates a circular magnetic field with strong disturbances around it. Plus, scientists mention electron rains in the ionosphere. These rains are what causes those bright, colorful auroras right below the storm. But how do space hurricanes form? To understand this process, we need to first talk about regular auroras, like the northern lights. The sun emits a stream of charged particles, also known as the solar wind, non-stop. And sometimes, this wind brings massive bursts of energy towards Earth. Luckily, Earth has a magnetic field that acts like a shield, protecting us from most of this high-energy solar radiation. But when solar winds are too strong, they can get into the upper atmosphere, especially near the poles. When these particles from the sun hit Earth's magnetic field, they release energy that lights up the sky in the form of auroras. Now, in a typical aurora, electrons from the solar wind excite nitrogen and oxygen molecules in the atmosphere, which then emit light, leading to colorful shows in the sky. Space hurricanes are similar, but they happen at higher latitudes, above the region where auroras usually appear. They create a swirling, cyclone-like effect that looks quite different. Scientists are still studying the exact conditions necessary for a space hurricane to occur. But they already know that, surprisingly, such storms happen during very calm space weather. This is the opposite of traditional geomagnetic storms, which need intense solar activity. Space hurricanes need just the right balance of low solar wind and northward-pointing magnetic fields. And even though these storms are uncommon, they aren't impossible, hence those unique swirling storms above the poles. When scientists observed the space hurricane over the North Pole, they noticed some shocking similarities to hurricanes on Earth. Just like the typical hurricane, a space hurricane has a central area where the plasma is calm. Even more curiously, the plasma in space hurricanes spins in a counterclockwise direction, which is like hurricanes raging in the northern hemisphere. The space hurricane also has multiple spiral arms, just like the ones you can see in satellite images of Earth hurricanes. Plus, the space hurricane doesn't need the strong solar winds that typically create disturbances in our atmosphere. No, it forms in periods of calm, just like how an Earth hurricane can only form if the winds in the atmosphere aren't too disruptive. Now, space hurricanes may be high above us, but they can still affect our daily lives, especially in areas related to satellite communications and space navigation. Those electron rains caused by the storm interfere with radio signals that travel through the upper atmosphere. It can disrupt GPS systems, radio communications, and radar systems. What's even worse, this interference can impact the orbits of space debris or space junk, which is already a problem for spacecraft and satellites in low Earth orbit. The storm's electron rain slightly heats up the atmosphere, which leads to extra drag on satellites and can potentially change their orbits. At the same time, the effects space hurricanes have on Earth aren't as direct and disastrous as those of hurricanes down here. They really don't pose any serious health risk to astronauts or damaged satellites. But researchers say that studying such storms can help improve predictions for satellite operations, especially for flights that cross polar regions. Now, interestingly, scientists didn't set out to find space hurricanes when they spotted one. The discovery was a total accident. It happened when Larry Lyons, a space physicist from UCLA, and his team were looking through satellite data for another study. In this study, they noticed unusually strong plasma flows in the polar cap, the region at Earth's poles where auroras usually don't appear. When they looked more closely, they saw that this plasma wasn't just flowing, it was swirling, creating a circular pattern with a bright auroral spot in the middle. The researchers were intrigued. They analyzed over 300 different space hurricane events that happened over a span of 11 years. These storms appeared most often in the afternoon during summer months. It made the scientists believe there might be certain times and conditions that could encourage their formation. Luckily, with new research tools and techniques, scientists have been able to identify space hurricanes with greater precision. And recently, they've spotted parallel storms happening near the South Pole as well. The most exciting thing about this research is that it might help us better understand Earth's space neighborhood and the way solar energy affects it. Scientists like Lyons believe that space hurricanes may not actually be a new phenomenon. They may have been occurring for a long time, but no one noticed them. Space plasma physicists point out that space hurricanes resemble a phenomenon people observed earlier. It's called high-latitude dayside auroras. At the same time, space hurricanes are much brighter, and they have stronger circular flows, which give them those hurricane-like arms. Understanding space hurricanes could eventually help scientists predict them. It would be useful for planning space missions and making satellites more reliable. Plus, by looking at these storms, researchers hope to create a more complete picture of how auroras behave at higher latitudes. And even though space hurricanes may seem purely like scientific curiosity, they can give us important clues about how Earth's magnetic field and atmosphere interact with the solar wind. And who knows? This understanding might even help us spot similar storms on other planets with magnetic fields. It could offer clues about magnetic storms beyond Earth. Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But Why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges. In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the sun are similar to this tousled hair. When the sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as storm quakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call storm quakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour, so it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest a storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.
We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the U.S. wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication, both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside. It's the 15th of January, 2022, 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hunga Tonga Hunga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. 2 seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption. The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, this discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, The sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum, and that's at its highest pitch. All because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors. Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or a pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them. Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around, because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines, such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. but for now we're pretty much safe. No major eruptions are predicted. Whew!
Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super-hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Global Catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared. So listen up. One day our sun will cool down and turn into a white dwarf. But this is not the worst thing for Earth. Before the star cools down, it will grow to an incredible size and arrange Ragnarok for us. Now, in case you don't know, Ragnarok is the fire apocalypse from Nordic mythology. So our star will burn down absolutely everything on our planet. But hey, don't worry, there's good news. This one day will come in 5 to 7 billion years. The bad news, though, is that almost all complex life on Earth will become extinct much sooner, maybe in 250 million years. But there's a small chance that our planet will be ruled by octopuses. Yeah, I know, this is too much news for the first few seconds. So let me break it all down for you, one thing at a time. We all hear about people destroying nature and polluting our planet. This is all true, but even without our intervention, the vast majority of living creatures on the planet will disappear, including ourselves. The reason is natural disasters and weather change. It sounds terrible, but it's not new to Earth. Scientists have found out that there have already been 5 mass extinctions. The last one happened about 65 million years ago, when dinosaurs disappeared. But life won anyway and took on many different forms. The 6th apocalypse may occur within the next 250 million years. Conditions on Earth at this time will be unsuitable for mammals because the level of carbon dioxide will be twice as high. This will happen because the sun will release 2.5% more radiation and it'll get too hot on Earth. The temperature in most parts of the planet will reach between 104 to 158 degrees Fahrenheit, and the entire land will turn into one supercontinent. In regions with high humidity, the temperature will be even higher, and of course, under such conditions, it will be difficult for people to walk in the park and play frisbee with dogs. No one will play with anyone at all. Let's hope we'll have colonized other planets by this time. Increasing solar fluxes will lead to a sharp loss of oxygen in the atmosphere. This means that in about 1 billion years, our Earth will look like the lifeless place it was about 2.5 billion years ago. That is, before the Great Oxidation Event. At that time, the air was filled with methane, carbon dioxide, and other gases, and the planet was inhabited by the simplest bacteria. Some of them learned how to make oxygen from sunlight and carbon dioxide. Throughout billions of years, they made so much oxygen that it became enough for the birth of new, more complex forms of life. And it seems we will return to these prehistoric times. Now, humans can't exist in such conditions, but some complex life forms hiding in the dark depths of the ocean might be able to adapt to the changed atmosphere and become the masters of Earth. These complex life forms are octopuses. There are many species of these animals. Some live in coastal areas, while others dwell in the deep waters of seas and oceans. And some species may be able to survive and create a new civilization. But why octopuses? Because they're some of the most intelligent creatures on Earth, and probably the most intelligent creatures among all the inhabitants of the dark depths. Octopuses can use surrounding objects as tools. For example, they can wear a coconut shell for protection or shelter. In laboratories, they've used various objects to complete mazes. These animals often escape from their water tanks to visit octopuses in nearby tanks. Yes, they have high intelligence, but not in the human sense. Their intelligence is more like a computer. You see, octopuses have neurons not only inside their brains, but also inside their 8 tentacles and large eyes. It's like a big data center, and their limbs sense the environment in exceptional detail, as if they were the brain. Not only their intelligence, but also their physiological properties might help the octopus survive if the apocalypse strikes. Its body has no skeleton. It can squeeze through any hole, slip past any obstacle, and their 8 highly developed limbs allow them to intelligently interact with their surroundings. Crows can bend pieces of wire with their beaks. They can throw stones into the water to raise the water level and get food. But they only have one beak. An octopus with its tentacles has at least 8 times more possibilities. They don't have spines, so they'll most likely build a civilization not on land but underwater, where it's much more convenient to move with such a body. To build a civilization, they'll need to find cheap energy. For example, hydrothermal underwater springs or tides in coastal areas. This will be a difficult task, but it won't be the most challenging thing for creating cities. It's very difficult for them to maintain social connections. By their nature, they are loners, who usually form groups of several individuals. But this is not enough to carry out large-scale construction of underwater urban areas. Parents pass on culture, history, upbringing, and moral guidelines to their children. They spend a lot of time and effort on education. Octopuses don't do this at all. The female octopus passes away shortly after laying eggs. The male octopus has only one mating relationship in its entire life and passes away shortly after the female is fertilized. So, in a sense, octopus cubs are born orphans. It's not surprising that it's difficult for them to build social connections. Over the past 50 to 100 million years, octopuses have not developed a collective feeling, and it's difficult to imagine that it will suddenly appear in the future. Perhaps something will encourage them. Who knows? Some scientists who study octopuses have noticed that over the past 10 years, some octopus species have shown certain social skills. Some live in groups of 10 or more individuals. If humanity doesn't ruin the lives of these animals by fishing and dumping garbage into the ocean, then they have a good chance of succeeding in conquering the planet. But if they fail, then the next candidates might be nematodes, those little white worms. Well, let's hope octopuses win. They seem cuter. They also may achieve a technological breakthrough much faster than we think, because when you have 8 arms, you work much better. Imagine these octopuses leaving Earth and flying to another galaxy, where they meet us humans. Do you think we could become friends? So let's say octopuses become a highly developed civilization that builds cities in the oceans. But they, just like humans, will have to think about colonizing other planets because of the upcoming Ragnarok. The sun keeps heating up and getting bigger, don't forget. Our star is currently in the most stable phase of its life. It has been in this phase for the last 4.5 billion years. But after another 5 billion years or so, the hydrogen in its core will start running out, and then the fun will begin. As hydrogen fusion slows, the core begins to contract. As the core gets smaller, it heats up until it can kick off another round of nuclear reactions, fusing helium into heavier elements such as carbon, nitrogen, and oxygen. Eventually, the sun will turn red and be so gigantic that it will swallow up Mercury, Venus, and possibly Earth. So, it may be Ragnarok not only for our planet, but for the whole solar system. No matter how tough octopuses are, they won't survive such a disaster. Earth is likely to burn down completely. Maybe it'll look like the moon, or it'll completely disappear. What will happen to the sun next? Its energy will run out sooner or later. Then it will shrink to the size of Earth and turn into a white dwarf. When a star goes out, it ejects a huge amount of gas and dust. Only the cooling core remains. All those outer layers will be floating in space, forming a beautiful nebula, and our solar system will become unrecognizable. Well, in some ways, it can sound pretty sad and scary, but hey, look at the bright side. Yeah, pun intended. It's going to happen in 5 to 7 billion years, so relax. Humanity has been living on Earth for about 40,000 years. If we compress the entire history of our planet into one 24-hour day, then the history of people will be equal to 1 second. If we achieve such a development in 40,000 years, what'll happen in 100,000 years, in 1,000,000 years, in 1,000,000,000 years? It's hard to predict. So how about going to the park and enjoying the sun at its best? Yeah, bring some sunscreen.